Algebra 2 people. Just in case you didn't get, you were overwhelmed by completing the square today, so I'm making you a little video. In case you forget, you can come and watch this video and see if it helps you. These say solve by completing the square. They're quadratic equations that you could either factor, if factoring is possible, but factoring isn't possible in these. So you have to find another method to find x, and you do it by making a perfect square trinomial, and that's called completing the square. First thing you want to do is get everything on the same side of the equation. And if we move this over here, what's going to happen is we're going to get a negative x squared, and that's not good. So what we're going to do is move everything to the other side. We get 0 equals x squared minus 2x minus 5. Now we're going to complete the square. As you can see, 5 is not a perfect square. So we need to put 5 on the other side by adding 5 to both sides. Now this one's a little backwards from what we did in class. So we're putting the 5 there. We're going to get x squared minus 2x plus we need a replacement term. And whatever we put here, we also have to add to the other side so that we can keep our equation balanced. Now I don't know if you remember, but the way we find our replacement term is we take our middle term, Mr. Middle, we divide it by 2, Mr. Middle, divide it by 2, and then we square it. That completes the square. That's going to be 1 squared, or 1. Then we're going to add that 1 here, and we're going to add that 1 here. And then we can carry on. Add that together, we get 6 equals x squared minus 2x plus 1. Now we have a perfect square trinomial. We know it's going to factor into x plus minus 1 times x minus 1. But since we made it a perfect square trinomial, we know it's going to be the same. So instead of writing this out twice, we would write x minus 1 quantity squared. So the whole goal is to make a perfect square trinomial so that we can factor it like this. Now we have to get the x by itself. So we're going to take the square root of both sides. We've done problems like this before. And this side's going to be plus or minus the square root of 6. And so we're going to get, on the left side, plus or minus 6, square root of 6. And on the right side, the square and the square roots cancel each other out, and you just get x minus 1. Finally, we still have to get x by itself, so we're going to add 1 to both sides. And we get our final answer of x equals, you can switch it around, but I won't do that so it doesn't mess you up. 1 plus or minus the square root of 6 equals x. Or you can write x equals 1 plus or minus the square root of 6. I didn't leave myself enough room for that one. Let's try another one. I left a lot of room for the next one though. Okay, this one, we can just leave this 2 over there because it's already not a perfect square. So we don't always have to bring it over and then bring it back. So we have x squared minus 5x. We need to make a perfect square trinomial by adding a perfect square right here, equals 2, and whatever we added to the left we need to add to the right. So how do we determine what goes in here? Why don't you try that? Turn off the video and see if you can figure out what goes next. Okay, hopefully decided. We take the middle term, we divide it by 2, and we square it. That goes in these two blanks. The actual answer to that, which would be 25 over 4. 25 over 4. Okay, do the next step, and then pause it and see if you got it right. Or pause it, do the next step, and then see if you got it right. Alright, we know that this is a perfect square trinomial because we made it ourselves. So we know it's going to factor into something quantity squared. We can make this 4 halves, which is the same as 2. They're the same. So that would be 29. Whoops, I meant to put it in fourths. That doesn't work. Fourths. We need it to be fourths, so it's going to be 8 fourths, which is the same as 2, right? So we add 8 fourths plus 25 fourths is 33 fourths. And then on this side we know it's going to be x times x. This sign always goes in the middle. And actually this is what goes right there. That's the square root of 25 over 4. Now we have it set up so that we can take the square root of both sides. So we're going to take the square root of this side and the plus or minus square root of this side. On the left, the square root and the squared cancel each other out, so you get x minus 5 halves equals plus or minus the square root of 33. And remember, this is the same thing as plus or minus the square root of 33 over the square root of 4. You can separate those. So we know the square root of 4 is 2. And then finally, we're going to add that to both sides, and we get x equals 5 halves. Typically you put the non-square root part first. Plus or minus the square root of 33 over 2. So hopefully that all made sense to you. And rewatch the video if you have trouble with these. Okay, I'm going to do a couple of the other lesson too, imaginary numbers. There you go. Okay, thing to keep in mind with imaginary numbers is anytime you have the square root of -1, it's equal to I, because you can't take the square root of -1 because nothing times itself can give you a negative. So that Euler guy came up with the fact that square root of -1 equals I, and the converse of that is true. If you squared both sides, you would get -1 equals I squared. So we're going to combine both of these concepts as well as adding the like terms in the next couple problems. Square root of -16. Well, that's the square root of 16 times the square root of -1. Just like we could take the square root of 12 and separate it into the square root of 4 times the square root of 3. As long as these two multiply together to get the initial one, you can do it. 16 times -1 gives you -16. Minus 2, and we learned right above here that I squared equals -1, so I can replace this I squared with a -1, and this is going to be -2I. The square root of 16 is 4. The square root of -1 right here is I, so that's going to be 4I plus 2 minus 2I. Now we have like terms. We're going to write this in a complex number. Complex number is A plus BI. This is the real part, and this is the imaginary part. So we're going to rewrite this. The real part, there's only a number of 2. 4I minus 2I is 2I, and that's your final answer. Why don't you try this one on your own, and then play the video after you either got it or got frustrated. So pause it now and try it. Okay, hopefully you tried it, and let's give it a whirl. So we have negative. Let's separate this out into two square roots. We have the square root of 4 and the square root of -1. Plus 2. Hopefully that was, yeah. Plus, now we have I to the 5th. We haven't had that before. We can separate I to the 5th into I squared times I squared times I. And you can see the bases are all the same, so you add your exponents when multiplying, and that gives you, this is the same as all these. Because when we add the exponents, we get this number up here. These aren't -2s, those are the dots for the i's. Okay, let's move on to the next step. Negative, the square root of 4 is 2. The square root of -1 is I. We can't do anything to the 2. Every I squared is equal to -1. This I is just himself. Then we keep simplifying. -2I plus 2. This is a real big 2 problem. We have a 2 times, this would be a positive, right? Negative times a negative is a positive. So we're going to get 2 times positive 1 is 2i. Minus 2i plus 2i cancel each other, so the answer is 2. Okay, hopefully you got that. Alright, and I'll be sending you the final lesson, which is a little challenging too, soon. If I forget, John, make sure you remind me. If you watch this video, send me a text or an email letting me know that you watched it.